In this video, we'll start writing our own functions. Functions are like building blocks of code. They let you write one piece of code that can be used multiple times in different situations. Let's start by looking at a function we've used many times before, np.mean. We'll make a new variable, random mean, and assign it equal to the np.mean of a. And we'll keep track down here in a markdown cell of what makes a function. First of all, we have the namespace for the function. In this case, that's np for numpy. And that means that this is a function provided by the numpy library. The function's name is mean, and we can refer to it anytime we want by using the namespace and that name. So there's the name, in this case, mean. We call a function by putting parentheses after its name. Calling a function runs the code associated with it. Inside the parentheses, we put a series of arguments. In this case, we have one argument, and that is a. And these can be different every time we call the function. In this case, we've passed a to the mean function, so we're telling it to compute the mean of a. If we add on the usual axis equals 1, this is another argument. And since we specified it as axis equals 1, that means it's optional. We could leave this out and it would automatically use some default value instead. Since there can be multiple optional values, we have to specify which one we're providing when we do so, hence axis equals 1. Finally, we have the return value. This is the value that the function returns to us when it's complete. In this case, the return value, we are storing it in random mean. Anytime we call a function, we're specifying these different parts of the function. Python's len is also a function. It's in the global namespace, which means that we don't have to put anything before it like np. Its name is len, so that's what we write to call it, and we give it one sequence of some sort as an argument. And the result that it gives us is the return value, which is the length of that sequence. We can also write our own functions. Let's make a function that multiplies its input by 2 and returns it. To do this, we use def to define a new function. We give it a name, in this case we'll call it double, and we specify what arguments it will take in. In this case it'll just be one argument, and we'll call it x. We put a colon at the end to tell Python that we're beginning a block of code that makes up the function. All of the function code should be indented so that Python knows when we're done and we go back to doing other things. In Jupyter Notebook, you can indent more by pressing Tab repeatedly, and you can reduce the amount of indentation by pressing Shift-Tab, and this keeps everything lined up nicely. You can see this function is taking in one argument, x. When someone later calls this function, whatever value they pass in to x will get assigned to x. Return is a special keyword that takes whatever expression comes after it and makes that the function's return value. So if we want to make this function multiply the input by 2, we need to make it return x times 2. So let's see if it works. We can write double 2 to call our double function while passing the value of 2 into x. And that returns the proper value. 2 times 2 is 4. Let's try running it on some different data. We'll do double an np.arange up to 4. And this time, because NumPy can handle element-wise arithmetic, we're able to double this entire arange. And now it looks like this works. We can call this function anytime we want to double anything. Let's make one more function. This one will be called add. So def add. If it takes in one argument, we'll call it x again. It will add 1 to it and then return it. We'll do that by saying y is equal to x plus 1, and then we'll just return that value of y. But if an optional second argument is passed in, it will add those two numbers together instead of just adding 1. We'll make this change by adding a second argument. We'll call it s, and we'll give it a default value of 1. And now we'll replace this 1 in the addition with s. Now if we call this with one argument, if we call add 3, this gives us 4 because it adds 1 by default. But if we add 3 and 4, now it will properly add those two values together and give us 7. Also notice that with this add function, we can write any code we want in this function body, and this can end up being really long if we want it to be. But variables declared in this function are local to the function. That means that if we have some variable y out here, let's say it's 10, even though we have some y inside, if we print out the value of y at the end of this, it doesn't matter that we're using y inside the function. This even works if we call the add function partway through. Let's say we do add 5. Even though we're calling this add function, it sets up a local y value, which is different than the y value outside. So that the y value of 10 stays intact. That should be enough to get you started working with functions. These ones were very basic, but we'll practice more complex functions later on.